Do you ever wonder how your bathroom scale calls you fat instead of just Y? It comes from cool tricks that engineers pulled right out of the very fundamentals of material science. Let's start by taking a look at how one of these old-fashioned dial scales work. Right under your fat ass, you get this lever right here which pushes down the spring and dial lever right here. Engineers know exactly the properties of this spring. There's something called the spring constant right here in this formula, which is usually something in pounds per inch or something like that. By doing math and swapping the formula around, you can place the numbers precisely on this dial here just to read exactly how much you weigh accurately through science. But why are we seeing digital numbers instead of a dial nowadays? Now let's replace the spring and dial with a basic metal pole, here with a little device we call a strain gauge. When it's glued to the side here, it will flex with the bar as you tug on it with the same lever system as before. Because all materials are elastic, which will act like a spring microscopically, which also stretches the strain gauge with the bar, when you run a current through these little wires here, they actually stretch and become thinner, which decreases the resistance and changes the voltage. Good luck breaking that spring. After the scale is assembled, technicians will set zero and then place a fixed weight onto the scale and set that to the fixed weight. Now that you basically told the device where zero is through calibration, the system can now draw a straight line between these 2 points with a fixed slope. In the engineering world, this is called an LTI system, or linear time invariant. This means it doesn't matter what point in time it is, it just means that this is that and that is this. So next time you want to say,
And I'm not fat, I'm big bone.
tell that to the material properties themselves. And if you're curious about anything else, leave a comment and follow.